Okay, so we're at the HiCam Studios in Austin. It's an amazing complex, and we're fortunate enough to be able to have them host for us to do some of our first podcast and website content for Austin STEM Center. I just wrapped up the interview with Peter Wang. It was really amazing, really fun, engaging conversation. And we find ourselves here with a few minutes left in the studio. And I wanted to find out if it was possible to take some time just to unpack a few more of the things that were on the table that Peter and I did not get a chance to talk about. So I'm going to go ahead and do that. The very first thing that I want to pull out is this here. This is a metronome, and the metronome has got this beautiful wooden case. And this is very old. This was my grandmother's. And I think as soon as we start to open it, okay, this will come off. We've got a little medallion in there, a little stamping Maisel. This is Maisel, and there's the stamp. But in here, this is a metronome. And you can see that we have different gradations. They start out very far apart. They come closer and closer and closer together. If I pull this out, there's a scale over here that is beats per minute. And we'll see down here, I think that says presto. Yep, presto, which means fast. So we take this weight and we move the weight down, we move the mass down. We have something that's moving very, very fast. As we move the weight up, and so there's a little spring that's wound in here. That spring winds up, and that is giving a little spring motor just enough energy to give this a little impulse at each side of the pendulum. And this is very accurate. This is accurate enough for a musician. To use to time and make a tempo. But the big piece of learning here is, I don't know if those gradations show up in light, but those little lines get closer and closer. And the reason the lines get closer and closer up at the top is because as the weight gets further and further away, the change to the system is more and more impactful. And so that's why down here, if you're off by 1%, there's only a small change in the presto. But further up in the scale, if there's a small change, it makes a very, very large difference. So that was my grandmother's metronome. And when I brought it in today, our shop steward, who's only 25 years old, he recognized that from his family and got emotional when he saw that one. So this is a metronome driven by a spring motor, and something that's interesting I thought to bring in today. After the metronome, Peter did identify that, but it took him a second. This is an Edison Ambrosol record, 4 minutes. So here it says 4 minutes. If we take this out, this is a wax cylinder, and it is one contiguous line, and it's a very wavy line, and the needle in the wavy line is moved, and the physicality of that needle moving onto a mechanical pivot, onto a little mica, like a diaphragm, and that diaphragm is a thing that is vibrating the air into a wooden horn. So what's interesting about this is 1888, and if you talk about a huge hard drive having 4 minutes of audio, that was kind of a big deal at the time. It is very delicate. It's wider here than here because the cylinder that it goes onto is actually tapered. It's a tapered cone, and it goes in and kind of locks on. The reason I bring this out and I talk to students about this is this is analog data. This data is all between 0 and 1 and always moving up and down between those values. There's an infinite number of values that can be had between 0 and 1. So this is an analog piece of data. This, on the other hand, is a player piano roll. And this is from the 1920s. And this is, you can actually put it over here so we can see it. This is digital in nature. And so it's ones and zeros. And so this is data to move cylinders that ultimately move the keys on a piano. And this is a player piano roll. So whenever I'm starting to teach students about coding, data, storage, information, they sometimes think that that has something to do with computers. And that's not true. The Jacquard loom was a programmable loom, and it was programmed with cards and data. And so I think now that hard drives have gotten so small and they don't even move anymore, it's hard for students to visualize what data is, what analog is, and what digital is. And so these two things as a pair, those are very, very meaningful. The next book by Samin Nosrat, who wrote Salt, Fat, Acid, Heat, and that's the book that we've used at Driven for the past couple of years as a cookbook. This book is absolutely amazing. It just came out. And if we can take a look at the book here a little bit closer on the inside, this book is something that I would highly recommend. We got the autograph there, or my wife did when she went to see her. Starts out with rules of thumb, and if we go back a little bit on how the book is organized, where is it? The introduction, here we are. So good things come in small packages, good things to welcome others, good things come in threes, good things to keep up your sleeve. And it always starts out here, good things, finger licking good things. And so I just love the way that this book is organized, but still very much a STEM book, but moving from Salt, Fat, Acid, Heat, which was almost fully a science book. This is bringing in a lot of the joy of cooking and sharing that cooking with other people. Going further down the list, we'll go with a not book. This is a project that we were considering. It is a kind of a bolt lock action, fully solid brass pen that is universal to every kind of cartridge. So at Driven, students use fountain pens, and sometimes fountain pens are not so practical, but just being able to understand how to manufacture something out of solid brass, use a generic cartridge. I think this is like a G3 cartridge, and then I don't know how far we can zoom in, but I'll try to put this together and then hold it still. It's just the brass has a beautiful patina on it. It's not lacquered, and being able to lock something in and out. I think machining brass is something that's extremely approachable to students and something that we're going to be exploring in the STEM Center as far as making things. And so this is one of the projects that we might approach with that. So we've got this book, which is The Nature of Code by Daniel Schiffman, Simulating Systems with JavaScript. And this is just beautiful, the way this is laid out. It's an open source book. This is not a book that you have to buy. There's an amazing website put up by the publisher, No Starch Press, and there is every piece of content on this website for free, not behind a paywall. And that's exactly why I paid full price for this book. And I'm buying many copies of the books for students at full price, so this project can continue. So if we're looking here, we start out with randomness, vectors, forces, oscillation, particle systems, autonomous agents, physics libraries. This book can be approached by a 10-year-old without much scaffolding, as long as they can start to access the programming, and they start to. If you take a look at that, here are full examples. So an example like this is like, what does randomness look like? It turns out that coding randomness is somewhat complex. Talking a little bit about random numbers. So there are so many projects in here, and then it gets into vector addition and acceleration, but really one of the most approachable books that I've seen. And the last thing that I would want to decode is Byron's The Elements of Euclid. This book, put out by Taschen, an excellent publisher, is I've seen and touched an original of these books once. I think the copy I was looking at was like $400,000. So this is much less expensive. But you're talking about something that was, I think this was, God, I don't even want to say the year, because I'm going to be off by a couple decades. But having some, it's barely a modern treatment of this, but looking at this kind of design language and understanding these symbols, understanding some of the Boolean logic that goes behind exploring and explaining. And so being able to read this as is, and understand these theorems, and these elements is very, very powerful. And it's not something that people need to wait until they are in geometry. And in geometry, we're into these 2-column proofs, and people end up hating mathematics because of it. But just getting a book like this in your hands before you get to geometry class, just for fun, just to puzzle it out and figure it out, this is an excellent, excellent book. So Elements of Euclid by Oliver Brine. I think it was Sir Oliver Brine. So yeah,